Okay, once you've downloaded Beam 4 and you've extracted the files into your folder, you're going to want to open up the program. So I have my folder here. I named it Beam 4. So just click on that. You're going to open Beam 4 End Users. Now from here, I would click on Beam 4 again, and I would open up this PDF guide. This guide tells you everything about Beam 4. I would read through this. It tells you everything you need to know. In order to access the program, you're going to need to go to Beam 4, the executable jar file. So open that up. And when you open this, you're going to get a blank purple screen that looks like this. And you're going to have File, Edit, Run options and Help. You're going to click on File, and you're going to have to create new optics and a new ray file to go with those optics. So if you were just getting started and you clicked on New Optics, you're going to get, actually you won't even have this, it'll be just a blank white slate here. I have optics I already created, so what I'm going to do is open up some optics and rays to show how this example works. So I open up an optics file that I have from a previous program, and I'm going to open up a ray file as well. Okay, and as I said, if you're creating these from blank, these will just be blank white screens. You have to literally label everything, all the little dots, the dashes, everything. So let me explain what's going on here. So let's start with the optics first. Actually, this is probably the better view. Actually, we're going to start with the rays first. Let me retract that. So we're going to start with the rays here. So what's going on here is, in the ray file, I have 6 rays. And I have these on the y-axis. So you literally have to just type this in, space it down, type this in, and you're going to put all these little dashes here. And you're going to put these semicolons here and all these dashes here. You have to manually do all this type of work on the program. So I'm going to start my rays at -1, -0.5, 0, 0.5, and 1. And this is actually the wavelength. This is in millimeters, I believe. Millimeters, if I'm remembering correctly. And I've colored it red. And I've left these ones blank. There's other criteria you can put in here if you need to, but this is going to be a very simple program. So basically this is going to propagate straight rays that are coming off the y-axis. So you could probably just copy these files, manually copy them just to get yourself started. From here, we're going to look at the optics file. Now this is going to be your lenses, your mirrors, whatever optical components you're using. So this is a 2-lens system, and then we have an aperture stop or a target to end the rays. So you're going to need to know your index of refraction, your position of the optics on the z-axis, the radius of curvature of the optics, the type of optics. If it's a lens, this could be mirror, iris. If you look in the manual, there's numerous things you can do. And then the diameter of the optics. You can change this. This is set defaults to a circular diameter, but you can do square apertures. It's pretty much unlimited with the types of geometries you can have. So once you have your ray file and your optics file created, and I'll explain more about what's going on with the optics file once I open up the program some more. So from here, once you have these files, you're going to want to run this, and to do that, you're going to go Run. And you're going to go Layout. And that's going to generate the actual ray tracing portion of the program. So let me enlarge this a little bit here. And then I'm going to zoom in here. So if we think to the ray file here, let me straighten this out. We're going to zoom on the axis here. Okay, these are the rays I created on that y-axis. So if we go back to the ray file here, we can see I created rays on this axis here, right along the axis. It doesn't display the numbers, but it shows you I have 6 rays, and I have 1, 2, 3. There should be 6 rays there. Actually, it looks like there's 4. 1, 2. Let me see here. I only labeled 5. I put 6, but there's actually only 5 here. 1, 2, 3, 4, 5. I could put another ray on here, but it works fine without that. But you can't exceed. So if I had 6 rays here and I put 7 in the column here, it wouldn't run the program. But if you have less than that, it will run the program. So you can see there's the rays. There's the rays. They're coming off the y-axis. And now we're going to look at the optical components, and I'll explain the optics matrix. Let me change the trajectory here so we can see this better. So there's the rays propagating off the y-axis. They're traveling in the z direction. And I'm going to change some options here. So I'm going to go options. Let me see here. Layout. And I want to turn off this refractor shading right now. And click OK. All right, and it took out the shading in between the optics so I can explain what's going on here. So this is the first set of optics here. We have the rays coming off the y-axis. Let me enlarge this a little bit here. Okay, and if we look at the optics folder here, my initial index of refraction is 1 for air, and here is my 1 for air. You can see it just propagates right through. So there, index 1. Now, at a distance of about 45 millimeters away from that y-axis, I have a lens with a negative radius of curvature here. This is a diverging lens. And this is actually, the lens has a thickness from this point to this point. So this is actually all, even though it's separated, it shows it's actually all one piece of the lens. So this is the curvature portion of the lens, and then this lens is just a single curvature piece. So the back of that lens would be flat. So the ray propagates through, and you're going to have to define both of these. So if you look at these first 2 lines, I have at z about 45, z equals 45, I have my negative curvature for my lens, negative curvature for my lens, and then it's a 9 millimeter diameter. You can see the dimensions of the lens here. And then if you look at your second line, now I'm defining the actual refractive index of the lens, 1.785. So in between here, this is where the refractive index of the lens is occurring. So this is how it's done in the programming. And now the back of the lens here, the flat portion, is at z equals 49. And obviously there's no curvature to this flat back piece of the lens. So you can see 0 for the curvature there. And again, I have to label that back piece of the lens as a lens. And again, the diameter, 9 millimeters, and you can see the 2 diameters match here. Now, once this beam exits the lens here, right, we're back through propagating through air again with a refractive index of 1. So that would be That's this portion here. So this is back now. The beam is diverging because it's a diverging lens. So we're back through air here. So again, we go from air to the refractive index of the lens in between the two pieces of the lens, one having curvature, one having no curvature. And then you're back propagating through air again with refractive index of 1. And that's showing on the grid here. So now, some distance away, 230 millimeters on the z-axis. So if I scoot this over, you can see I have another lens here. And this is a positive lens. It has a positive curvature. So the positive curvature of 0.0097, again defined as a lens. And now this has a much larger diameter, 75 millimeters. And you can see that this diameter lens is much larger than the initial lens. And the back of this lens, it's pretty close here, but you can see that there is a thin distance here. So you have the curvature, and then you have the backing of the lens here. That's at a distance of 238 millimeters. Now that's 238 millimeters from the y-axis, not from the front of this lens. So everything's defined as distances from your y-axis. So you can see again, there's no curvature on the back of the lens. We have the refractive index, which is the refractive index in between the curvature piece and the flat piece of the lens here, 1.517. And again, the matching diameter of 75 millimeters. And then from here, again, the beam is going to propagate through air again. And it's going to propagate through air all the way till it reaches its target. And you can label this, again, so there's 1 for propagating through air. This is my distance away. Again, this is from the y-axis. No curvature. You can see here, no curvature for the target. And this is just an aperture. There's numerous labels you can have here for your target. And the diameter of 100 millimeters. So that's a basic program for a collimating beam expander. So the beam starts off small. It expands with a negative lens, comes back to a positive lens, collimates the beam all the way to its target. So this would be something used to basically collimate a laser beam. So again, here is the optics component, and here is the ray component. Feel free to try and duplicate this program.